Welcome, class, to the Intro to Java Programming. In this lesson, we'll review many ways to convert the value of one data type to another data type. We have touched upon some of these in prior lessons, but we'll cover more specifics on boxing and casting. It is a romantic thought that we could choose the correct data type in the beginning and never need to convert the data from one type to another. The problem revolves around the fact that you will be working with other developers along with programs and methods that have a specific purpose for a value where the data type conflicts with another process that will be using the same data later. If you are the only person working on a program, you are aware of the data used for the full life of the program. You should be able to make correct decisions on the data type. In reality, the code you work on will be shared by many other developers. It could be another coworker, former employee that left, former employee that was terminated, code written by a third-party vendor or library, or code that is outsourced by contractors. Some developers are less experienced and make poor choices. Other developers have a different purpose for the data type used for a variable. Imagine a third-party vendor built a service that reports the number of soccer goals scored by the league for a given day. Goals would be a whole number, which leads us to an int. Since you cannot score half a goal, there's no reason to use a double. Now let's say you're tasked to report the average number of goals scored in a week. You would collect the data needed for specific days. The final answer will be a new rational number, not a whole number. The double is a good choice for this result. An integer and a double are different data types. Each developer had a specific reason for that data type used, yet in the end, a conversion is needed. Converting one data type to another will happen frequently, so let's go over some common examples. Let's start with an easy one, boxing. Autoboxing and unboxing are done automatically in Java, but you should be aware of the process. Autoboxing is the conversion of a primitive type to its non-primitive object type or wrapper class, like converting an int to an integer or a long to a long. If you remember from lesson 5, an integer is a wrapper class for an int, meaning an integer class can do everything an int can do, but an int cannot do everything an integer can do. Placing the value of an int into an integer is very easy. Let's try this in code. Let's go to our basics project in IntelliJ, close any open class tabs. Let's create a new Java package called converter. Inside the converter package, let's create a new class called Autoboxing test. Let's make some space. Copy in this first test. In this first test, we created two variables, one primitive and another non-primitive. Here we placed the value of the primitive type into a non-primitive type. Notice there is no compiler error. If we run this test, it should pass with no execution errors. In this next test, we will autobox all the primitive types and print the results. Here we set all the primitives. We create the non-primitives, and then we will output the values. Let's run this to see the results. Correct. Unboxing is the process of converting a non-primitive object to its corresponding primitive type, like converting an integer to an int or a long to a long. Inside our basics project, let's create a new class inside of our converter package. Let's call this new class Unboxing test. Let's make some space, copy in the first test, import in these objects. The first test will convert a non-primitive to a primitive variable. Here we set the value for a non-primitive. Here the primitive variable is declared and assigned with the non-primitive value. Notice there is no compiler error. If we run this test, it will pass. In this next test, we will unbox all the non-primitives and print the results. Here we set all the non-primitives. We create the primitives and then we output the values. Let's run this test to see the results. Very good, Karthik. I will turn you into a developer one of these days. Unboxing a null value will create a null pointer exception. Here's a test that will unbox a non-primitive with a null value into a primitive data type. Here is a non-primitive value set to null. On this line, we try to unbox my integer to my primitive int. IntelliJ is giving us a warning that this may produce a null pointer exception. Let's run this test anyways. A primitive cannot hold a null value. This is why we have a null pointer exception. NPE is a common acronym for null pointer exception. You need to be aware of possible null pointer exceptions when unboxing. Let's comment this line out. Let's run this to produce the output. Autoboxing and unboxing allows us an easy way to convert an int to an integer and an integer to an int. Converting one primitive to another primitive requires casting. In Lesson 7, we talked about casting. Casting is the process of assigning a value of one type to a variable of another type. There are two types of casting: implicit type casting and explicit type casting. Implicit type casting is converting a smaller primitive data type into a larger primitive data type. Explicit type casting is converting a larger primitive data type into a smaller primitive data type. Now you must consider the size of each primitive. They use a different amount of memory. Since a short uses 2 bytes of memory and an int uses 4 bytes of memory, putting a short into an int will work easily. This is implicit type casting. Now consider the reverse. The int's 4 bytes of memory will not fit into the short's 2 bytes of memory. Data will be lost, so you must explicitly tell Java to convert the larger value into a smaller data type. This is explicit type casting. Here's a line of code that will cast my primitive int into my primitive short. Casting occurs here. My primitive int is cast to a short represented by the data type in parentheses before the value to be casted. The result of this piece of code is now a short data type and can be stored in my primitive short. Inside our basics project, in the converter package, let's create a new class. Let's call it casting test. Let's make some space, copy in this first test, import in these objects. The first test will perform implicit casting. Notice we create a primitive byte variable and assign the value 42. On the next line, we create a primitive short variable and assign the value of the primitive byte variable. Placing 1 byte of memory into 2 bytes of memory is implicit type casting and very safe. The following lines cover the int and the long. Let's run this test. And it passes. This next test will perform explicit type casting. Here we create a primitive int and primitive short variable. There is a compiler error for trying to store an int into a short data type. IntelliJ is suggesting that we cast the value to correct the error. Let's comment this line out. Here we explicitly cast the primitive int to a short. The result is now considered a short and will be stored into the myPrimitiveShort variable. If we run this test, it should pass. Time for a Coach Joe challenge question. As you should all know, the primitive byte can only hold a value from 0 to 255. What happens if a short value of 300 is explicitly cast into a byte data type? Let's write a test to see if this is an error or if data will be lost. Here is a test where a primitive short has a value of 300. We cast the value into a byte data type and store the value in the myPrimitiveByte variable. Notice there is no compiler error. This gets a little complicated with binary values, but you should get the idea. In binary, a byte can hold a value from 0 to 255. If the value is 256, another byte is needed to hold that value. The value 300 is stored with 256 in the second memory location and 44 in the first memory location. When the value is cached to a single byte of memory, only the first byte of memory is casted. The second byte of memory is lost. Let's run this test to see the output. Notice there's no error and the resulting value had data loss. Honestly, explicitly casting a larger data type into a smaller data type is an indication of poorly designed code. You need to have a very good reason to be explicitly casting this value in the first place. Casting does not work for non-primitives. This test will try to use implicit casting for a non-primitive. Notice the compiler errors. These data types don't match. Casting to a non-primitive short does not work either. Notice the compiler error. Let's comment these lines out. Each non-primitive has a built-in method to convert to another primitive value. Let's expand IntelliSense here. You can see that there's methods for short value, int value, long value, and many others. Now that the result of the short value method is a primitive, Autoboxing will be used to place the value into the myShort variable. Let's run this to see the output. I have an idea that might be a little extreme but shows possible situations where boxing and casting may occur. Here we have a test. Here is a private method that divides two numbers and returns the result as a double. The variable top number will be passed into the divideMe method and unboxing will occur. Top number is a non-primitive double and the method is looking for a primitive double. The variable bottom number would be passed into the divideMe method and implicit casting will occur because the primitive int is smaller than the primitive double. The variable result double calls the divideMe method. Since the method returns a primitive double, Autoboxing will store the result into the non-primitive double. The variable result int calls the divideMe method. Since the method returns a primitive double and that data type is larger than the expected primitive int, we must use explicit type casting to store the result. Not a real-world example, but it does illustrate all four combinations. Let's run this test. And it passes. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of autoboxing and unboxing with a primitive and the non-primitive wrapper class. Implicit and explicit type casting was covered, including several examples. Also, you should be aware that no matter how much planning you have with the data types used, there will always be a need to convert them to another data type. In the next lesson, we'll cover type conversion. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!